Hello dear students, welcome to the series of sessions where I am bringing few topics, subtopics which are important for JEE Advanced and also for mains. In today's session I will be talking about statistics and I call that as a bonus marks in JEE Advanced also now. Already we were getting bonus marks in this topic in JEE mains for many years. Almost in every paper you get one question of statistics and that is not very difficult. You just need to learn 2 or 3 concepts and based on that you can solve that question. So this thing is now happening in JEE Advanced also. This year in 2025 there was a question in matrix match and you will not believe, you don't need to solve all the parts given in that matrix match. If you know few ideas which I will be sharing here, you will skip 2 parts and you will just come to the answer, almost answer, just by solving 1 or 2 options, and these key ideas I will be discussing in this session. I will be telling you what are the basics, but I will not be teaching you that. You can find them in books. In fact, I have mentioned them in my session. In my session notes also you will find all the things at one place. So please download that session note, that will be very useful for you. My main agenda would be those extra key points I will say, which will be helpful to solve questions faster. In fact, as this chapter is now coming in advanced, we may expect few difficult questions also. So I have anticipated some 4 or 5 scenarios from where they can give you a question. So let's see how those scenarios will be catered, and I have tried to explain them through few examples in today's class. Okay, so let's start. First I would like to talk about Daksh, who got All India rank 15 in JEE Advanced 2025. He got full 120 out of 120 marks in maths, which is a one very rare feat achieved by any student across country. Not every year students are getting that kind of marks. He was student of Arambh 20 to 25 where I was teaching him maths for 3 years. The ideas of these sessions are something that we used to discuss in his batch. Few of the ideas came from Daksh also. Dear students, I am still occupied with my Arambh students, 𝒂𝒃𝒃𝒃𝒃𝒃𝒃. In 𝒂𝒃𝒃𝒃 we are teaching students for JEE Advanced. Okay, for this year 𝒂𝒃𝒃𝒃 2026, I am sharing with you the QR code of Telegram channel. Please join that channel so that we get all related information to 𝒂𝒃𝒃𝒃 at one place. When will be the test, how many tests, or many more information you will be getting at one place. So please join this channel. So dear student, this is me, Surendra Jain. I am teaching maths for last 14 years. I have been teaching for JEE Mains, Advanced, Olympiad, CMI and ISI also. So let's start this session. So in the statistics, so this is the basics, I think we all must know, and I will say not only the session notes, please refer some book also, maybe NCERT or something like this, so that you know all these things like central tendencies, mean, median, mode, what are they, what are the formulas. Okay, for ungrouped data, for grouped data, their key properties, their key weaknesses, I have mentioned here. Please go through the session. I think there is nothing I should be explaining it to you. You can just read through the session notes and you will understand what exactly these points are. Then median, then this formula. Dear students, this formula is one very important formula. I will say, I have seen one question in JEE Mains based on this formula, and people tend to tend not to remember this formula, and if you do not remember and there is some use of this result, you may lose your marks. So please read this formula and remember it. Try to do few questions so that you can apply this formula in your exam. Similarly, the mode, there is a formula for mode also like this. So please go through these things. Again I will say, you please do not take chance, because even if something they have asked based on this result and you are not able to solve it, it will be it will be unfortunate thing. So there are just 2 things that you need to remember extra. One was that formula of median, and then for mode. Okay, now I will be starting with measure of dispersion. Okay, so that is the starting points in the syllabus of your JEE Mains, JEE Advanced. So here I will be starting with the dispersion. So dispersion is a measure of variations. If you are given certain data and they are having different values, like marks of students in certain batch, so they will not get same marks, all students will not get same marks. So we want to study the variation, that how many marks more, how many marks less, and how they are changing. Are we having very small variation? Maybe the mean is, let's say, 30 and all the students are around 28, 29, 30, 31, 32, like that, or there is a huge gap like 0 marks also and 50 marks also. So this kind of thing, if you want to study, this is done with the help of dispersion. There are 3 things that we need to know. One is range. Range is nothing but the difference of the highest value, the largest value, minus the smallest value. That's the range. Okay, there has not been any question on range, but I will still convey this thing to you because it is given in NCERT book. Then mean deviation. Okay, what is mean deviation? In the mean deviation, what we are doing, we will be finding the difference of all the data. Let's say x1, x2, x3, x4, all data are given. Okay, now we want to know the mean deviation. So we will be taking the difference of every data from certain mid figure, or you can say average figure or mean figure. That can be mean or that can be median. Okay, so all the data will be subtracted by that value. Let's say a, this a can be mean also, arithmetic mean, it can be median also. So we will be subtracting all the data by this. We will take mod of all of them. Okay, and then we will take average of all these values. So summation of all these mod xi minus a divided by the n, that will give you mean deviation. Okay, the formula for grouped data, where frequency is given fi for each data, just fi will be multiplied with that particular mod divided by summation of all the frequencies. Okay, in case your data is given in the form of class, let's say 0 to 10, that frequency, 10 to 20, that frequency, and so on. In that case, x1, x2, x3 are always supposed to be taken as the midpoint of that class. For 0 to 10 it should be 5, for 10 to 20 it should be 15, like that. Okay, now regarding this mean deviation, there is one very important thing. In fact, all these important things I have listed towards the end of this session. First, let me tell you that important point here regarding this mean deviation, but in the end also I will repeat, I will mention it again. Okay, so the important property is the minimum property of mean deviation. The mean deviation is minimum if you calculate it about median. Suppose your median and mean are 2 different values, and if you take the mean deviation, you can check it will be minimum when it is taken about median. What is the reason for that? The reason for that is the same which I explained it to you in minimum area concept in my previous session. If you remember, I told you if there is a function that is strictly increasing, okay, and we want to know the minimum area. So this is similar thing. Please try to connect with that. You will definitely able to understand why minimum is coming when it is taken about median. Now let me tell you here also, and I will repeat it later on also, that based on this minimum property this year, what I was saying, you are not supposed to solve each and everything. You could eliminate 2 options right in the beginning. You don't have to solve 2 parts. Maybe B and C parts you were not supposed to solve because of this property, if you remember. Okay, so there are few things, if you keep in your mind, you can do questions very smartly. So this is one of the things that you have to remember. Okay, then coefficient of mean deviation. Dear students, coefficient of variation we study with the reference of standard deviation, but I have seen coefficient of mean deviation also in some questions, although it may not be directly in syllabus, but they may ask you. So you should be prepared that mean deviation divided by that mean value, whether median or mean. So if you get this ratio, you will get coefficient of mean deviation. It will make this thing dimensionless. If you are measuring, let's say, length, your mean deviation will be in meter or centimeter, whatever. Your A will also be in meter or centimeter, but when you take the division, it will become dimensionless quantity, it will be just number. So coefficient of mean deviation. Okay, this is useful for comparing variability between 2 sets with different averages. Okay, variance. one very important thing, in fact, it will not be wrong if I say that more than 80% questions are coming based on variance, especially in JEE mains. But in advanced, they have asked questions on mean deviation also. Last year itself they asked question on mean deviation. So variance, dear student, what is variance? In this case, the data that you are given, x1, x2 and so on, xn. First of all, we have to find the value of mean, x bar, although you have some other method also where x bar may not be required. So x1, x2, xn, so you get the mean value x bar. Now we will be taking the difference of each data by the mean value. So you will be getting this data, x1 minus x bar, x2 minus x bar and so on, xn minus x bar. Okay, if you remember in mean deviation we put mod here so that we can make all the differences positive, because if x bar is mean average value, then some of them will be positive, some of them will be negative. So we want to know the variation, so we have to count their magnitude. In case of mean deviation we did by putting mod on it. Here we will be putting square here. So if you put square on all of them and you take their average, you get variance, which we denote by sigma square, not sigma, sigma square. Okay, if you simplify it, that xi minus x bar whole square summation and then whole divided by n, it comes out to be like this. And there is one very important thing related to this expression, please understand, and it is equal to, please see what is this, it is average of squares. It is average of squares. You can check, I have written here it as summation xi square, so x1 square plus x2 square plus x3 square and so on. So it's average of squares divided by n and then minus square of average, square of average. Okay, so this is how your variance can also be calculated. So you need not to take the difference like this, you just take the square of every data. Okay, take their average minus square of that average will give you the same value which you are getting from here. Okay, very simple proof, but I am avoiding it. You can find this in any book, very simple proof of this thing. So but this is one very important, I will say. Then for group data you just need to multiply by frequency. Okay, in case it is given with class, then you have to choose xi as the mid value of that particular class. So this is how this variance is defined. Now this regarding this variance, few things, because in variance we are doing the squaring. So suppose you are counting the variance of, let's say, some readings that are for certain length. So variance will not be in meter, it will be in meter square. So that is one thing. Unit of variance is the square of the original unit, like data. If it is in meter, then variance will be in meter square. So don't get confused. You have to do something so that you bring it down to meter only. Combined variance is possible to calculate for two groups if their individual means and variances are known. In fact, I will talk about this thing in the session. Suppose you are given two sets of data, x1, x2, x3, xn, y1, y2, y3, yn. Now you combine them and you try to find their variance, how we can find it. There are 2-3 scenarios, I will talk about that one by one in my later part, but that we will definitely talk in this session. Then there are properties related to variance. If you add every data by certain number, okay, then your variance doesn't change. It will be same as the old data. So that's a very useful thing. You just have to add or subtract some number, whatever fits best or whichever you feel will make your calculation easier, and then you find the variance and you still get the same value of variance. Okay, that's one thing. If you multiply the entire data by some constant, some non-zero constant, let's say lambda, then it will be lambda square times the variance. Okay, if you change your xi to axi plus b, so here only change will be because of a square, not because of b, because b is just the addition like lambda here, so there will be no change because of b. The change will be only because of this a square into variance of xi. Okay, so these are the key properties of this variance. Standard deviation is just the under root of this variance, nothing else. As I told you, variance gives you square of that particular data. The unit will be square of that given data. Here, if you want to know that variance in your unit, like you are measuring length, you want it in meters, then you just have to take the under root. So there is nothing different than in variance and standard deviation. You just need to take the square root here. Properties independent of origin. As I told you, if you subtract the every data by some fixed value, so if you do that here also, because it is just the under root of variance, so standard deviation will not change. Okay, dependent on scale. If you multiply the every data by some number, as I told you there, lambda, then standard deviation will become mod of lambda times. Okay, so if I say standard deviation of, let's say, lambda into xi, so it will not be lambda into standard deviation of xi, rather you should write it as mod lambda, because if you are multiplying by a negative number, standard deviation should still be a positive value. So these are key properties that we should know. Okay, coefficient of variation is just sigma, that is standard deviation divided by mean into 100. One important thing I have, I think, already told, but once again I will repeat, that standard deviation or variance are always calculated about mean, not about median. In case of mean deviation, it can be about both mean also, median also, but here it is about mean only, arithmetic mean. Okay, so this is the measure to compare the consistency. The larger value of CV means more variable your data, lesser the value of CV, your data is more consistent. Suppose there is one class where average is 30, there is another class where is average is 30 again. But here all the students are about 30, like 29, 30, 31, 32 only, whereas in the other class students are having marks like 0 also, 1 also, 2 also, 50 also, 48, 49 also. So in the second case you can expect larger value of this CV. In fact, that value of variance will also be more in this case, but CV gives you a better idea. CV gives you better idea. So this is a best measure to compare the stability or consistency or variability, you can say, of two different data sets. Okay, now I am coming to these key ideas that I was talking in the beginning, and now I will say this session is going to give you very important ideas, and I will say you must know them, you must ponder upon them, that how they are coming. Now, so first thing is saying, if data ranges from A to B, suppose your values of x1, x2 and so on, xn, they are such, the least value is, let's say, A and the greatest value is B. Okay, it may not be here, but somewhere the least value is A and greatest value is B. Okay, then the maximum possible variance will be A minus B by 2 whole square. You cannot get variance more than that. Why? Very simple reason. First of all, you will get maximum variance if your datas are either A or B only, because if you choose to have few more datas which are having values in between, definitely you are having more data towards the mean value, so your variance will drop. What I am saying, if you have only these kind of values, maybe A multiple times, B multiple times, okay, then your variance will be maximum. If you replace A by some value which is bigger than A but smaller than B, then your variance will definitely be lesser, because you have introduced a quantity that is close to your mean than your earlier value A. Okay, so that is one thing. Now, what will be the variance here? Let's understand this. Suppose I subtract each data by A plus B by 2. What I am going to do? I am subtracting each data by A plus B by 2. So this A will become, I think, B minus A by 2. This A will become B minus A by 2, and so on. And this will be, all the B will become, I think if I subtracted by this, I think minus sign will come here. Sorry, minus sign will come here. In this case, it will be B minus A by 2. In this case, it will be B minus A by 2. Okay. Now, as I told you, by subtracting each data by a fixed number doesn't change the variance. So in this case also, variance will remain same for this data or this data. Here you can see the variance, as I told you, it is the average of average of squares. So if you take the square of all these numbers, I think it is same. Every data is same, b minus a whole square upon 4, and it will be added n times, and minus mean square. Mean I am writing it as mu. So this n will cancel with this thing. Now you may have your mean to be equal to 0 if equal number of a, equal number of b's are there. But if equal number of a and equal number of b's are not there, then your mu will not be, your mean will not be a plus b by 2. In that case, after subtraction, your mu will not be 0. I will repeat what I said. I said if all a and b are equal in numbers, say 10 times a, 10 times b, then your average will be a plus b by 2. So after subtraction, your mu will become equal to 0. In this case, your standard variance will be this b minus a whole square by 4, because mean is 0. But whatever you number of times a you take or b you take, mu will be either 0 or it will be non-zero value, but mu square will be positive always or 0 at most. So in that case, your maximum value of variance will occur, that will be equal to b minus a whole square by 4, and that will happen if you take equal number of a's and equal number of b's. That is all from my side. I hope you have understood. So what I have said, if your data are from a to b, then your maximum value of variance can be a minus b by 2 whole square only. Okay, I have one question based on that. Please see. Suppose you are given, this is the frequency distribution x1, x2, x3, x5. Now x1, all xi lies in the range this 5, 15, and all the frequencies are positive integers. Okay, now they are asking standard deviation cannot be. So in this case, because all the data is starting from 5 going till 15, so the maximum possible variance can be 15 minus 5 by 2 whole square. That will be, I think, 25, yeah, 25, and that's the value of variance. In fact, that sigma square has to be less than, and strictly less than, because 5 and 15 both are coming with open brackets. So sigma square should be less than 25, so standard deviation should be less than 5. Okay, what they are asking? Standard deviation they are asking. Okay, so I think I have written the options wrong. I should have given this as 4, 5, 6. Okay, if it is given 4, 5, 6, you can see your standard deviation cannot be 5, cannot be 6, it can only be 4, and that is definitely possible. You can adjust the values of x1, x2, x3 so that your variance, standard deviation can be 4. But this can definitely not be 5 or 6 if your all x are lying in this interval. I hope you have understood what I have tried to say. Okay. Next thing, mean deviation of any data is minimum when it is measured from median. I think I have talked about this earlier also. I am repeating this thing again because it is very important. In this year question, in this year 2025, there was a question. I have intentionally not taken that question because you may be writing some PYQs near your JEE exam. So that's why I have not included that question in my session. I could have taken that also. But in two of the options, they asked mean deviation about median, mean deviation about mean. And the two options were having different values. So obviously you can identify which one has to be matched with which one. I hope you are getting what I am saying. So mean deviation of any data is minimum when measured from median. I have repeated this 3-4 times. Please remember. The reason for this I have told you is coming from that minimum area concept. You can compare that thing with this thing. It's same thing, because when you are taking the mean deviation, you are actually doing what? Xi minus, let's say, median. If I take median, let me call this as A, okay, and we are taking the summation. Okay, in this kind of data, we can write all the data in increasing order, and you can compare with this as an increasing function. And then for increasing function, if you remember, I told you that this fixed line, okay, let's say y is equal to c, and if you are looking for this area to be minimum, okay, this used to be minimum when this point is the midpoint of this A and B. If this is A plus B by 2, then only you get these area to be minimum. Here also similar thing is happening. That's the reason why mean deviation about median is minimum among any other thing, like mean deviation about you take mean, or mean deviation about mode, or any other number. If you fix like mean deviation about, let's say 10, I have to find, and 10 is neither median nor mode or whatever. In that case, if you try to find all the mean deviation, and if you compare, your smallest value occur when it is about median. I have repeatedly said this thing so that it goes into your, in your mind, you do not forget it. Okay, so don't say that why I am repeating this again and again. Next thing, variance, as I told you, is average of squares minus square of average. Okay, and because variance is always positive quantity, so we get one very important inequation also from here, that sigma xi square upon n is greater than sigma xi upon n whole square. This is also known as RMS greater than or equal to AM. In fact, this is actually RMS ka whole square greater than AM ka square. Equality will happen only if all x1, x2, x3 are, are same numbers. If they are not same, then there will be a difference. Okay. Now, based on that, I have taken one question. Suppose you are given these two data set, xi, I think it should have been I here also I. This summation of xi is 80 and summation of xi square is 400. We have to find the possible values of n where all xi's are real numbers. So in this case, as I told you, this 400 upon n should be greater than or equal to 80 upon n whole square. That's it. Okay. Now you can check, this n comes out to be greater than or equal to 16. So the value of n cannot be less than 16. It has to be 16 or 17 or 18. In fact, it will be 16 if all the data are same. You can check. If it is 16, then every data will be 5, 5, 5, 5 each. So 5 into 16 is 18. In this case, this will become 25, 25, 16 times. So it will become 400. Okay. I think, yeah, I have taken this question also here. So here you can see x1, x2, x3, x4, x5. You are given their sum is 8, sum of square is 16. Then they are asking the largest possible value of x5. In fact, this could have been x5 to x1 also, x2 also, x3 also. For any x1, x2, we can find the possible value of this x5 or x1 or x2. So how this we can do it? Please see, if I take 4 numbers on one side, so the summation of these 4 would be x1 plus x2 plus x3 plus x4 is equal to 8 minus x5. If you take the square, x1 square plus x2 square plus x3 square plus x4 square, that will be 16 minus x5 square. 16 minus x5 square. Now same thing you just have to apply. This 16 minus x5 square upon the data, number of data is 4. So upon 4 has to be greater than or equal to 8 minus x5 upon 4 whole square. You just need to solve this inequation and you will get your answer. I think this x5 comes out to be less than or equal to 16 upon 5. So this a into b will become equal to 80. You can check. Okay. Dear students, you have used AMGM, you have used AMGM, HM also. I will recommend that you should remember in this order, that first is RMS, then greater than or equal to AM, greater than or equal to GM, GM greater than or equal to HM. Okay, so these things we must know. Root mean square. RMS stands for root mean square, where we are squaring, taking mean then root. Root mean square ko you just read opposite, square mean root. So it will be like squaring, so x1 square plus x2 square and so on, then mean, so divided by n, and then take root. So RMS is this thing. AM we all know, GM we all know, HM we all know. So this is the order. And this RMS greater than or equal to AM is also one very useful thing. Please note this thing in your kitty of results formulas. Will be very useful. Although this class is of statistics, but maths is totally interconnected. So this concept of variance, the formula of variance where we are getting, leads to this RMS greater than or equal to AM also. Okay. Now, I will now talk about if we have to combine different data sets, how variance, standard deviation will change. Please understand. Here we are given x1, x2, xr with mean as x bar and standard deviation as sigma x. Standard deviation I have written. Similarly for y1, y2, ys. Here number of data is not yr, it is ys, and then z1, z2, z3, zt. So all the three data sets are having different number of sets, different number of data points. R here, S here, and T here. Okay. Now their means are x bar, y bar, z bar, and let's say mean of the complete data set is capital X bar and standard deviation is sigma. So can we find sigma? Can we find x bar? I think you might have done for x bar already. I will just repeat how x bar is calculated, and then I will talk about how this formula is coming for standard deviation also. So dear all, please listen carefully. For this x bar, I think this r plus s plus t, the total number of data into x bar has to be the sum of all the data set across three different sets x, y, and z, and that should be equal to r into x bar plus s into y bar plus t into z bar. That's it. So this result will give you how we can find x bar. Very simple, very intuitive, I think. Now let's come to the standard deviation thing, how we can find the standard deviation. Now dear all, please understand, if we are looking for standard deviation sigma x, let's say standard deviation square, let's say variance, it will be equal to 1 upon r summation of xi square minus, I think, x bar. Okay, so here what I can do, I can write sigma xi square as equal to r into sigma x square plus x bar. I think very simple result from this formula, and that we must remember, that is average of squares minus, square of average. Okay, so taking this on the other side, summation xi square will be equal to this thing. Now similarly, sigma yi square will be equal to s into sigma y square plus y bar square. Similarly, sigma zi square will be equal to t into sigma z square plus z bar square. Okay, now if you add all these three things on the left hand side, that is nothing but the summation of all the data. Let me call them as now capital Xi. Okay, so that will include xi data set also, yi data set also, zi data set also. Now the way I have proved it for this thing, proved this thing, I think I can write this as r plus s plus t times the combined variance plus combined mean square, and this sigma xi square will also be equal to, if you add these three things here, so r into sigma x square plus x bar square plus s into sigma y square plus y bar square plus t into sigma z square plus z bar square. I think I have written neatly here, so you can check how it is coming. So that's the result. Now you may not remember it if you wish, but you should understand that we have eliminated the sum of squares. We have eliminated the sum of squares, and then we have found the relation between combined variance and mean with individual variance and means. So this is how we can find the combined variance, combined standard deviation, you can say. Okay, I will take one question based on that, although I will suggest in this kind of question also use that property where each and every data is subtracted by fixed value to make your calculation simpler. I will tell you how it can be done. One more thing, Nacho. If you are given two data sets x1, x2, x3, xr, y1, y2, y3, yr, but they both are having equal number of data points, r here and r here, then you want to create x1 plus y1, x2 plus y2, x3 plus y3, and so on. Or maybe In all the data you are taking the difference, x1 minus y1, x2 minus y2 and so on. Now you want to know what will be the combined mean and combined variance. I think combined mean is very easy to find. If mean is x bar here, mean is y bar here, then for this data set the mean has to be equal to x bar plus y bar or x bar minus y bar, depending upon if you are taking plus or minus. So mean is very easy to find. Now how to find standard deviation? The standard deviation, that's a result, and how it is coming, please understand. If we are looking for standard deviation, let's say for x plus y data, when all x1, y1, x2, y2 they are added. In this case, what I will do, I will write this from the fundamental definition, that is x1, not x1, I will say what happened? Yeah, so sigma of xi plus yi, okay, and then take the difference from their average. So that will be x bar plus y bar and whole square of this thing and whole divided by n. I think that is how we find the variance. Sigma x plus y whole square will be given by this thing. Now, and I will be ranging from 1, 2, 3 up to r. Now you can write this expression inside sigma as xi minus x bar plus yi minus y bar whole square divided by n. Now if you open the whole square inside this, it will be summation of xi minus x bar square plus yi minus y bar square plus 2 times xi minus x bar into yi minus y bar, and this entire thing inside this summation divided by n. Okay, now I think we are done. If I split these terms in 3 parts, so sigma of xi minus x bar square upon n is nothing but sigma x square. Similarly, sigma of yi minus y bar whole square divided by n is nothing but sigma of y whole square, and the remaining thing you can take 2 outside, 2 by n you can write outside, summation xi minus x bar yi minus y bar. Okay, so this is how this formula is coming. If you are taking minus sign, then there will be minus here. If you are taking minus here, let me use some different color. So if it is minus here, then it will be minus here, it will be minus here, you can check. Then it will be minus here, then this will be minus here. So if you are combining 2 data sets, your mean and variance will change with this result. In fact, I have made one more general scenario. Suppose you are not only changing the data by adding or subtraction, rather you are multiplying by some number a to one data set, b to another data set, and then plus minus. In this case, it is just a square times sigma xi square plus b square sigma y square plus minus 2ab outside and summation xi minus x bar yi minus y bar, and that's it. Okay, this also can be derived from there itself, not difficult at all. Yeah, so I have taken 2-3 questions, 2 example actually. One is that first of 2 data samples has 100 items with mean as 15 and standard deviation as 3. The another group, sorry, not another, the whole group which is having 250 entries, mean 15.6, standard deviation root 13.44. We have to find mean and variance of the second group. Okay, so my first group is having 100 entry points, its mean is 15, its standard deviation is 3. The second data set will be having 150 data point because total is 250, and the whole group we know about this mean is not aware, we are not aware of, let's say so mu, and in this case let's call this as sigma. Okay, now if you combine them together, we are getting the total data set as 250 points, 250 number of data points, and the mean value is how much? 15.6. Okay, and the standard deviation is root 13.44. So how we will find mean? I think finding mean is very easy. What you can do, you can multiply this 100 with 15 plus this 150 into mu, and that should be equal to 250 into 15.6. Dear students, you might have done these things on 10th grade also. Like in this calculation, if I decrease the entire data value by 15, let's say, okay, so in that case this mu value will also decrease by 15. Okay, my calculation will become very easy, because if I am subtracting the entire data value by 15, the average of this will become 0. Actually, what are you doing here? You are subtracting the each thing by 15. So 15 minus 15 will become 0. Here it will be 150 into mu minus 15, and on the right hand side it is 250 into 0.6 only. I have subtracted by 15. This has become 0. And this will become equal to 25 into 6 is I think 15. So this will be 150. So here mu minus 15 will be 1. So here mu minus 15 will be equal to 1. So your mu value will be equal to 16. So one thing, we have got mu as 16. Now we have to find the variance also. So what I will suggest in this kind of question, you may use that result I told you earlier, but let's do one thing. Let's reduce entire data by mu, that is 15. The sorry, not mu, it may not be mu, it can be any number. So it is your choice whether you want to subtract by 15 or 16 or 15.6. To the ease of the calculation, I will go with 15. You could have gone with 16 also. So if you subtract the entire data set by 15, I think here average value will be now 0. Okay, this we found 16, now it will be 1. Okay, here it was 15.6, it will be now 0.6. Okay, now if you remember how I connected the variance of two different data sets, I connected it with the help of sum of squares of the data. So in the first case, let me write it here. I think I am not having sufficient space, so I will be using this space. So for first data set, sigma xi, I am writing it, that will be having 100 data points, sigma xi square actually upon 100. Okay, that will be equal to the variance, that is 9, not 3, because 3 is I think standard deviation, so 9 plus the square of average, which is 0. Similarly, for second data set, sigma of yi square, now the entries are 150. So this divided by 150 will be equal to sigma square, which we are not aware of, plus just 1. I have used that formula only, that variance is equal to average of square minus square of average. So it will be, you can say 1 square here. Now for entire data set, if I write for entire data set, it will be sigma of xi square plus yi square divided by 250. Or let me do one thing, let me write not this way, let me call this as z. But please understand, this data set sigma zi square upon 250 is nothing but the sum of sigma xi square and sigma yi square, and that will be equal to the variance square, that is 13.44 minus 0.6 square, actually plus 0.6 square. Okay, now you know sigma xi square plus sigma yi square will be equal to sigma xi square plus sigma yi square has to be equal to sigma zi square, because this zi are nothing but those 250 entries which are either there in x or there in y. Now you just put these values, so 900 here plus this will be going 150 there, so 150 sigma square plus 150, and this will be 250 going that side, and it will be multiplied with 13.44 plus 0.36. Okay, not difficult calculation at all, because I think you can divide by 150 all the sides, both the sides, so the calculation will not become very difficult, and then you can find the answer. I think the sigma square comes out to be here. Let me just check, then I'll comment. Yeah, 16. Sigma square is coming out to be 16. And one more thing, Vacho, I think this was a very bad board work, you can say. I started from here, then I went here. I think this was really very bad board work, but I hope you understand what I did here. Okay, now one more question, and let me try to do little better this time. Two data sets with 20 entries each. One is X, one is Y. The standard deviation here is 4, standard deviation here is 3, and you are given summation of xi minus x bar into yi minus y bar is equal to 90. Then they are asking sigma x minus y. I think you remember the formula, or if you don't remember, just understand the concept, how it is coming. It will be equal to sigma x square plus sigma y square minus 2 times summation of xi minus x bar into yi minus y bar. And 1 minute, I think divided by 20 also it will come. Yeah, divided by 20 also it should come. Let me just check. Sorry, 1 minute, just 1 minute, Bacho. Maybe I am doing it wrong. By n was there, na? By n. Yeah, I think this will be divided by n also. Both are having r entries, so r will be there, because the summation is coming like this. Yeah, divided by r will be there. Here also divided by r will be there. My mistake. Divided by r will be there. So in this case, divided by 20 will be there. So you will be getting sigma x square as 16 plus 9 minus 2 upon 20, and here we are given this summation as 90. So that will be only 16. So again answer is 16. If you are looking for sigma, it will be 4. Sigma x minus y will be 4. Okay. So dear student, I think you might have seen this video, this portion earlier also, but I am again repeating, I am saying this thing again, that's upon r would have been there. I will change it in my session notes. Please go through it. There you will not find this mistake. Okay, I hope you understand why r is coming here. Why r is coming here? Because when I am taking the summation, I have to divide by n also. The number of data point n I have to divide. I am just checking. Yeah, n. I think it should be there. Yeah, it should be there. Coefficient of mean deviation. I have repeated this thing. Dear students, you have seen coefficient of variation. That is variance. Sorry, standard deviation divided by mean. But coefficient of mean deviation, that is not something that I have seen at many places, but it is something that is very parallel to coefficient of variation thing. Coefficient of variation thing, that is equal to standard deviation upon the mean. One more thing I would like to tell you, dear students, I have seen coefficient of variation defined as either this, or in percentage you just multiply by 100, but they don't say coefficient of variation in percentage. I have seen in few questions that coefficient of variation can be written like this also. Okay, so most of the time I think it is written as into 100, but try to understand the meaning through the question. It could be simple ratio also, or if it is mentioned in terms of percentage, it should be multiplied by 100. Coefficient of mean deviation is defined like this. Okay, so please don't get confused. What I am saying, if it is in percentage, then multiply by 100. If it is not multiplied by 100, then simple ratio standard deviation divided by x bar. Okay, with coefficient of variation, I have not got very simple answer. that whether it should be this or this, but from the question, from the language of question, try to understand whether they are talking about this or talking about that. Okay, from the value also you can anticipate whether it is with multiplication of 100 or not. One more thing bachcho, I will like to talk about here, and then 2-3 questions more, and that is number of data set that lies below or above a certain number k. Suppose I give you question where you are given that there are certain data set like 20 students are there and their average marks is 62, okay, and variance value is 30. Okay, now I want to know how many students can fail this examination at most, or at least if scoring less than 40 is known as failing that marks, failing that exam. Okay, so you are given number of data point 20, you are given their average value, you are given their variance, okay, and you are given student will fail if score is less than 40. Now we have to find the number of student that may fail is. Now please understand how we can do such kind of question. In this question, what I will suggest, you make your data so that your mean value becomes 0 once again. Okay, so what I am going to do, your number of your marks student wise are, let's say, x1, x2, x3 and so on, x20. Now I will suggest you subtract 62 from all of them so that your new mean value will be now equal to 0. Okay, now in this case your variance, that is 30, will be equal to summation of xi minus 62 whole square divided by 20. You can take this 20 that side and this will become equal to 600. Okay, so what we are getting? We are getting summation of xi minus 62 whole square is equal to 600, I is ranging from 1 to 20. Okay, now if any student is getting less than 40 marks, which means after subtracting that 62 which I have done for every data set, okay, so fail means in new data set it should be less than minus 22. If getting less than 40 is fail, so if you subtract 62 you get minus 22, so fail means your mark should be less than minus 22. Okay, now if you are scoring less than minus 22, that means your magnitude will be even bigger than 22. It can be minus 23, minus 24 and so on. So in this case, try to understand, if let's say one student failed, so at least one of that data point value has to be less than minus 22, whose square will be greater than 484. If you do the squaring of this minus 22, it will be 484. So if one student got failed, then pertaining to that particular student data, this value will be 484, in fact with open bracket. Okay, whereas we are having only 600 on the right hand side. So if suppose two students got failed, at least 484 value will be there for that student also, but you can see the sum cannot be equal to 600 if I assume two students got failed. So what is the conclusion? The conclusion is that at most one student got failed, because if one student got failed, then this data value will be 484 or bigger, and rest other 19 data values here, the square of all those 19 values will be such that sum is so that it becomes equal to 600. I hope you are getting what I am saying. So here the number of students that may fail can be 0 or can be 1. It can be 0 also. Suppose your all the values are, say, we just need to make sure that this value is equal to 600. Now these are 20 data values. If I divide it by 20, it will be equal to how much? 20, so I think 30. So if each value is equal to 30, I think you will get no student getting failed, and still this value is coming out to be 600. So 0 is also possibility, but at most one student can fail, not more than that. Now this question could have been asked otherwise also, that how many student at most can score more than 80 or maybe more than 90. So that also can be done same way. You just have to subtract the entire data point by the mean value so that you don't have to subtract any mean value. Your calculation will become simpler and you can conclude such things. Dear students, subtracting the entire data set by particular value, especially mean or maybe some other value, is one very important, one very crucial thing I will say in this chapter of statistics, especially in your syllabus. Okay. Now please see, this is one question. Mean of 5 distinct integers is also integer. Okay, let their variance lies in the interval 5, 6. You have to find the mean deviation about mean. So here they have not given data, they have given there are 5 distinct datas, distinct integral datas actually, and whose mean is also integer. Okay. Now this is a question where little bit of number theory is required, not much. Simple, you should know the squares of integers and how do they behave. The sum can be, the sum of different squares can be how much or can be at least how much. So these things will be required, and this kind of questions can definitely be asked in JEE Advanced exam, I can say. If I am not wrong, there was one question similar to that only maybe in 2020 or 19 in some topic. They created that question with the help of number theory. Okay, so here what we can do, please listen carefully. So here we are given 5 distinct integers, okay, and their mean is also integer. Now there can be 2 scenarios, that mean value is among those data values. So let's say those integers are n1, n2, n3, n4 and n5. Let us assume first that the mean value, that is integer, is none of these data points n1, n2, n3, n4, n5, which means if I subtract the entire data value by the mean value, let me call mean as small m. So if I subtract the entire data point by m, you will be getting n1 minus m, I am calling this as n1 dash, n2 dash, n3 dash, n4 dash and n5 dash. The entire data set is subtracted by m and we got this thing. Now in this case the mean has to be equal to 0. So if mean has to be 0, these 5 distinct integers has to be such their sum is 0. But if mean is not from among n1, n2, n3, n4, n5, none of them will be 0, which means few will be positive, few will be negative. I hope you are getting what I am saying. Okay, now one more thing before I go further, the summation of all these ni dash square divided by 5 has to be from 5 to 6 as they have given. Variance lies in 5 to 6. So summation of ni dash square has to be within 25 to 30. So the range of this sum of squares after subtracting from mean, because then only I don't have to care of that minus square of average, because average I have made now 0. So here this summation has to be from 25 to 30. Now coming back to this thing, if no element is 0, so some of them will be positive, some of them will be negative. Let us assume they are written in increasing order. Okay, so there can be possibility that just one integer is positive and other are negative. If that is so, in this case, because all the integers are distinct, the negative values has to be at least -1, -2, -3 and -4, and to make the sum 0 it has to be 10. Then obviously the sum of their square cannot lie in 25 to 30, you can say, because 10 square itself is 100. I hope that is clear. Which means we cannot have one positive rest negative or only one negative rest positive. Maybe we should have 2 positive, 3 negative. In this case the least value of 3 negative values would be -1, -2, -3. When I am saying least, it is least in magnitude. So -1, -2, -3, and to make this sum 0, these 2 entries has to be such that the sum is 6. So it can be either 1, 5 or it can be 2, 4. I think only 2 possibilities, because they cannot be same. 3, 3 is not possible. So 1, 5, 2, 4. Now you can check the sum of squares is again exceeding this value of 25 to 30, because in this case 25 plus 1, 26, 27 plus 4, 31. I think it has exceeded. In this case it will be 16 plus 4. 16 plus 4 is 20, 20 plus 10, 30 plus 4, 34. So this is also not possible. So far, two possibilities, they are not possible. Now, with this, I can also conclude it is also not possible to have 2 negative and 3 positive, because it is just the negative of that thing, and doing the squaring will give you same thing. So, what we have concluded that having this integer, mean value integer other than these n1, n2, n3, n4, n5 cannot give you this result, which means now I have to consider one of the value as mean, okay, which means one of these dash values has to become 0, if one of them is equal to mean, when you are subtracting the entire data by that value of mean. Okay, so in that case maybe you will be having one value 0 and just one value as positive, okay, and then there will be two values, one value 0, one positive, then 3 will be negative. In this case, if 3 values are negative, okay, so -1, -2, -3 is the least possible magnitude of negative values, because all of them are different. So here it has to be 6. Now once again you can check, this exceeds this limit 25 to 30. So in this case we will have to have this 0 in between, okay. In this case the least value of negative will be -1, -2, and to make this 0, I think here we will be having 1 and 2, so that the sum is 0. No other possibility. If it is -1, -2, sum 3 can be possible only with 1 and 2 if they are distinct integers. Then if you square and take the sum, I think it is coming out to be just a 10. It is coming out to be just 10, which is also not coming in this range. So we may have to increase the sum of this negative value. So mid value is 0. Here I will be increasing it -1, -3. Okay, 1 minute. 0, -1, -3. Yeah, now fine. In that case, the sum of positive values has to be 4. This can be only possible with 1 and 3, because distinct values you have to take. In this case, if you take the sum 9 plus 1, 10, 10 into 10, 10 plus 10, 20. That is again less. So that is also not working. If you are taking the sum of negative integers to be -5, -3 we have seen, -4 we have seen, -5 if I take, there are two possibilities, -1, -4. In this case, here you will be having two possibilities, 1, 4 or 2, 3. If your sum of negative integer is -5 and that is with -4, -1, in that case you can check, it will be 16 plus 1, 17 into 2, 34, going out of range. So that is also not possible. Similarly with 2 and 3 also it is not possible. I think the only possibility it comes out with -3, -2, 0, 2 and 3. Let me check. 9 plus 4, 13 plus 13, 26. Yeah, that's correct. So this is what your data should be after subtracting from the mean. Okay, so whatever your data set is, after subtracting from mean, it has to be -3, -2, 0, 2 and 3. If you take your sum of negative numbers even more in magnitude, you can check your sum of square will exceed this 25 to 30 range. So that's the only possibility. And how we have concluded, I have told you one by one with this case making, you can say. Here we are looking for the mean deviation about mean. I think already we have subtracted the data by mean and we are getting these things. To get the mean deviation, we just need to add the magnitude of these numbers. So that is 3 plus 2 plus 2 plus 3. So I think 5 plus 5, 10, and there are total 5 data points. So answer will be 2. So answer will be 2 for this question. Okay. So dear students, in this session, I have talked about first central tendencies, not in detail, then dispersion, definitely in detail, and then I told you key points. If I revise, if I repeat what key points I have talked about in this session. So I started with this point number A, which was if your data ranges from A to B, the maximum possible variance is A minus B by 2 whole square. Then I told you that mean deviation, if it is found about median, it will be minimum. If you take about if you take about mean or any other value, it will be more than what it is about median. So this is one very important thing, you have to remember it. See, this RMS square is greater than AM square. That comes by the definition of variance or by the formula of variance, you can say. See, 3 point. Then fourth point, if you have to combine the 3 data points, how to get the combined variance and mean values. It can be 3 different data sets with different number of data points in each of them. Also, you may have same number of data sets, same number of data points into different sets, and you are adding, subtracting the corresponding values. That way also you can find the combined variance values, combined mean, I think you can directly find. So combined variance value. Here I made some mistakes, so please take care of this thing. I talked about coefficient mean deviation similar to CV, and then I told you if you are given certain information like number of data points, their average value, variance value, so what can be the upper cap or lower cap on certain data values that exceeds some number or they are less than some number. This I told you through this example. Dear students, I was trying to find different questions, difficult questions which may come in JEE Advanced, so that I can include them in this session. That was the objective. If I find any more type of question, I will definitely share it with you. But from my side, these ideas are must. Please remember them while you're solving questions of statistics. These will not only help for JEE Advanced, but also help for JEE Mains. In Advanced, we should expect more difficult problems, more conceptual problems, and that you will be able to solve through these ideas which I have shared with you. Sorry, I got distracted because of this phone. So that is all for today. Thank you so much, bachcho. See you into the next session. Bye.